polar covalent bonds have partial charges. That's to say delta minus and delta plus on either atom. But we can have full charges that we call formal charges. We can calculate whether a specific atom in a specific molecule has a formal charge by considering the number of valence electrons in a general element and then subtracting the number of electrons in a specific atom for that specific molecule. This is done by counting half the number of bonded electrons and all of the electrons in lone pairs associated with that atom. Let's look at a simple example. In these early cases, we're going to make life easy for you for a change by indicating electrons with different shapes and colors so that you can visually rapidly identify what electrons are associated with what atoms. To start you off, we're going to think about methane. Well, here is part of methane, the carbon. So straight away we can see that for this specific atom in this specific molecule, there are 4 electrons. Let's finish off methane. So here there are 4 hydrogens. Nothing has changed. There are still 4 electrons associated with the carbon. But we will see how the formula comes into play. Well, here we have 4 bonds with 8 electrons in total. So half the number of bonded electrons are associated with carbon, and that would be 4. In this example, there are no lone pairs. Now, in general, if we were to go to the periodic table and calculate the valence electrons for carbon, that would come out as 4. So to do the mathematics, 4 minus 4 equals 0. This carbon is neutral. It doesn't have a formal charge. That's not always the case. Here we can see a depiction of nitromethane. Notice the minus with a circle around it and the plus with a circle around it. These are formal charges. Sometimes atoms will contribute more or less than the number of valence electrons for that element in order to fill the shell. This is true for nitromethane. We'll come to that in more detail in a moment, but first I want to give you a neutral example with lone pairs. Let's move from methane to ammonia. Again, very simple. Just the nitrogen. How many electrons does the nitrogen have in this specific molecule? Hopefully you can see straight away it's 5. Let's finish the molecule off with its hydrogens. Okay, still 5, right? Let's go back and see how it fits with the formula. Well, there are 3 bonds here, so a total number of electrons of 6. So half the number of bonded electrons, therefore, is 3. There's 1 lone pair with 2 electrons. So the total number of electrons associated with nitrogen here is 3 plus 2, which equals 5. We turn to the periodic table. How many valence electrons in a general nitrogen? 5. Thus, the charge is 5 minus 5, which equals 0. Again, the nitrogen here is neutral. It doesn't have a formal charge. Let's take a look at an example with a formal charge. We know one already. It's nitromethane. Here is the nitromethane Lewis structure. First thing to notice is the carbon is very similar to the carbon we found in methane, and so we're not going to focus on it. Let's take a look at the nitrogen. What you can visually see is that the nitrogen has 4 electrons in this molecule. We can calculate the same answer by observing that there are 4 bonds with 8 electrons, where half of them are associated with the nitrogen. So that's 4. There are no lone pairs here. Thinking back, we know that the number of valence electrons for nitrogen is 5. The formal charge of this atom in this molecule is 5 minus 4, which equals plus 1. This nitrogen has a plus 1 formal charge. Next, we will look at the upper oxygen. As you can see, we have 6 electrons for this oxygen in this molecule. There is one double bond that has 4 electrons, and of those, half are associated with oxygen. So that's 2 electrons. There are also 2 lone pairs with a total of 4 electrons. Thus, there's a total of 2 plus 4, which equals 6 electrons. The number of valence electrons for a general oxygen is 6, so the formal charge for this atom in this molecule is 6 minus 6 equaling 0. So we are viewing a neutral oxygen. Finally, let's look at the lower oxygen in this case. As you can see, we have 7 electrons for this specific atom in this specific molecule. We can get this answer also by observing that there is one bond with 2 electrons, and half of them are associated with oxygen, so 1. Also, there are 3 lone pairs with 6 electrons, so the total number of electrons associated with this oxygen is 1 plus 6, which equals 7 electrons. Again, any oxygen has 6 valence electrons. So the formal charge on this oxygen in this molecule is 6 minus 7, which equals minus 1. There is a formal charge of minus 1.